So the title is Exploit Spotting. Let me introduce myself. My current employee is Web Sensing Corporation. Okay. Okay, thank you. So I'm currently performing researches related to malwares and exploit detections. And my former employer was EI Digital Security, and I developed IPS security product, and I did a lot of vendor patches regularly. And I found some vulnerabilities like MS06, 070, and CE Arc Server 1. And I usually used static analysis to find the vulnerabilities. And my tool that I'm going to talk about today is Darangrim, and it's a binary diffing tool. And I did it for something like a weekend project. So I'm telling this because this is very relevant to what I'm going to talk about. So at this point, I'm going to give you some simple question here. It's very simple. Do you really believe that if a patch is out, every security problems will be gone? Something like if there is some 0 days are out, people are always talking about some kind of patch release date or something like that. So people seems like they believe that if a patch is out, looks like every problems will be gone and every system will be secure after that. But I think the answer might be none for this question, because if we look at the configure worm like a few years ago, actually last year actually. So actually it used MS08, 067 RPC vulnerability to propagate through the internal network, and the vulnerability itself was fixed at least a few months ago before its outbreak. So, and how about the drive-by exploit and exploit packs? Usually they contain a lot of old vulnerabilities, like 1 year old, 2 years old, something like that, and it still works. And they use a lot of obfuscations to evade IPS or web filters. And looks like that's what is happening. And how about the exploit frameworks like Metasploit and Core Impact and Canvas? It's not usually about the 0 days. I didn't see many times that any exploit frameworks released any 0 days themselves. They usually write something from POC or something from wildlife exploit. So looks like one-day exploit, what I'm talking about now, might be still very important. So let's talk about exploit and security product relationship here. So with exploit, we are talking about POC, just proof of concept that is disclosed on full disclosure list or something, or exploit packs that is sold by if you pay $500 or something, maybe you can buy this one, the exploit packs. And there are other things like a drive-by exploit that is uploaded to some website and people just visit that website that they are infected or something. So, and there are other exploits like exploit frameworks like Metasploit, Core Impact, and Canvas. And they are exploits, but they are still a security product that can do some kind of real-world testing. So these are exploits. And how about the security product? By security product, I meant antivirus and web filter and mail filter and IDS and IPS and vulnerability scanner Retina or something like that. I only know Retina because I worked for EI. Anyway, there were basically what I have seen from the security industry until now is they are trying to create a lot of signatures for all the threats they found. So it's all about the signatures. If there are some wildlife exploits, they create signatures for that. And there are some 0 days out, they create signatures, or they make some analyzer modules that actually can parse that kind of data and catch that exploit. So it looks like still it matters to find one-day exploit, because looks like there are many computers and personal computers and corporate networks that hasn't been applied the patches for some reasons. For example, if someone is running some corporate website that is selling some stuff, and I heard that just rebooting the system takes sometimes more than 20 minutes or something. So during the time, the company can't make money, so they just postpone their recycle date or something. So they do patch every few months maybe. So usually Microsoft releases every month, every second Tuesday, I remember. So they just postpone the patch date. So during the time, there are some time frame that the systems inside their network can be infected. And looks like, so the conclusion here is that 0 days are very serious concern, but 1 days are also very dangerous still. So there are, you might wonder, you might question me, is there any examples that actually use the one-day exploits or any examples like that? So I just collected some of them here. So there was one MS07004. It was a VML issue, and actually he used my tool to diff the binaries, and he created the exploit within a few days, I remember. And the next one is MS08067, and I believe it was found by, not found, analyzed by Steve Ridley, and looks like he used my tool to diff the binary, and he created the binary. From his blog, he said within few hours. And how about the MS10024? Actually, this is some undisclosed vulnerability that found by, actually not found, it's a kind of caught by Core Lab, and they found that Microsoft silently patched some issue within their system, within their DLL, not telling anyone about that. So, and now you can know that the binary diffing matters to create exploits. With the POC, you can write exploits very easily compared to without POC thing. So you can just refactor the code and put something there, and it may take a lot of time, but compared to the situation without POC, it takes relatively little time. And if you don't have POC, what option do you have? You only have you can read the vendor's page, advisor pages, or something like that, but you will never find anything useful there. They are just saying something very vague and some kind of very abstract thing there. So the only option for now is binary diffing. So you just diff the actual binary they released, and you can find the exploits. And how about the IPS and vulnerability scanners? They need to protect some unknown, unknown threats before they emerge. So they need to diff the binaries before someone creates some exploits for that vulnerability that hasn't been disclosed before. So there are some good news here. Microsoft started some program, a program called MAPP. And how many people heard about MAPP here? Can you raise your hand? Still not many people. Looks like maybe 10 people here. So yeah, it's not that known yet, looks like so, but still it's very useful to security vendors, because they can get the actual report from Microsoft saying the details, the real technical details about the vulnerabilities, the point and the crash report and the how to reproduce, and they actually provide something like a POC code reproduction code or something like that. So, but I found that they are still hiding things usually. Like if they release a patch, sometimes they just saying. They are just saying that they patched just one vulnerability, but actually someone just dipped the binary. They find that they patched like 2 or 3 more. So I'm going to show the examples here after some talk about the tool itself. And the current limitation with the current binary dipping tools are I found that the managing files are too boring. You need to download the patches and you need to store them and you need to sort out which files to dip. And Microsoft releases 12 patches, and it takes too much time and effort. And the other problem is that if you dip some binaries from Adobe or something, then it shows more than 3,500 entries dipped. So even though you can go each entry and you finish each entry by within 1 minute, it takes a few days. So it's not feasible at all. So I'm releasing Darungrim 3 in a few days, and it has web interface, and each web interface, and people feels very comfortable with web interface, and it has a bin collector. It collects binaries and it manages all the binaries for you, so you don't need to worry about the version numbers and the file names and company names. You don't need to worry about that. And it also has some score index number called security implication score. It shows what function has more security implications inside it. So let's see. The architecture change is the old one is left side and the Darungrim 3 is on the right side. And the old one had only GUI and dipping engine and some basic sets of functionality. But Darungrim 3 has above that, it has a Python interface above a dipping engine and database. And it also has a bin collector and web console. And this is the main page. It's just web interface. And it has a bin collector. It collects the binaries for you, and it has some kind of experimental feature downloading MS patches automatically for you. And here's the screenshot for the diffing itself. If you see around here, you can see that the patch number MS08067 here, and the OS name here, Windows XP SP3, and it shows the file name here, net API 32. And the cool thing is that it finds the original binary to diff automatically using the file name and the version string. It just compares the version string and it finds the most closest one so that it doesn't create too many results. So let's talk about security implication score. The objective of binary diffing is actually locating the vulnerabilities as quickly as possible. So I introduced some numbers called the security implication score. But there are a lot of noises caused by something like a feature updates and code refactoring or compiler option change. If the vendor changes optimization level a little bit, then it will create totally different binary. Then it will create some diff entries more than 3,500 or something. Then it will waste your time. So using this number, security implication score, you can just sort out that kind of stuff out of the result, and you just need to look into something that has meaning. And also, disassembler doesn't work that well. It's very advanced now, but it still generates a lot of false positive entries. It sometimes treat some data entry as a code entry, and it treats some code entries as data entries. So it's using some kind of heuristics, but sometimes it doesn't work very well. And how about the security implication scores working? It's something like, let's see, it's working like just using signatures right now. So it's a signature-based scoring system. So if you find some patterns inside the patches, then it will treat that part as a kind of security-related part or something, and it like accumulate all the scores, and it just compares the scores with other entries, and it just shows which one is more likely to have some security patches. So you might wonder what kind of signatures. So here's simple examples, like how about string length? If there was some buffer flow issues, the only way to fix is to check the length of the original string. So in that case, you will call string length. And how about the string, safe string API? Like Microsoft SDL, how many people know about SDL, Microsoft SDL? How many people heard about that? Yeah, looks like more people know about that now. So it's a kind of program like they are like a development life cycle thing, and it's like originally SDL meant in other like companies it meant like a software development life cycle or something, but in Microsoft they changed it to like a secure development life cycle or something. So it's about like methodology for like developing some secure product. So from that guideline, maybe they need to use some safe string API. So if you find that API, it means that they fixed something in that function. How about the 0x FFF, some patterns like that? It means that they are checking some big numbers. So maybe you can just use this constant to check some integer flow. I will show the real example now after this. So the cool thing is that it's customizable. So the whole engine about the security implication score is written in Python. So it's a kind of example from me. So you can just rewrite the logic yourself, or you can add the signatures to yourself very easily because it's written in Python. And the actual question is, you might wonder, does it really work? So I tested with some Adobe binaries. It's called acroaldi32.dll, and they recently, like a few months ago, they patched to like a 9.3.3, and I diffed with 9.3.2, and it created like a 3630 functions modified. And I found that the entries with SI's number greater than 0 was only under 692, and the functions with SI's number 1 was only under 70. And actually the entries with SIS number 5, it looks like it's under 20, so it saves you a lot of time. You don't need to look at like other entries with SIS 0. So looks like it's working. So I'm going to show some demo here. So actually, the actual diffing process takes a few minutes, so it's not feasible to run that thing real time here. So I prepared some examples here. So here, this is the main menu. Actually, this is some SKArt. It's a Darren Grimm. And there are menus like files import and files list and Microsoft patches list and about this screen too. So if you go to files import here, it just shows some like input box. And if you like put something like C Windows and press the import, it will take like 10 or 20 minutes to import all the files from C Windows directory. And it will like import all the PEP files from there, and it will create the index for them. So you don't need to worry about the version numbers or where to find the files or something like that. You don't need to worry about that. So actually, you can use like you just need to set up some virtual images for every OSs, and you just need to import them from like if the machine is, you just need to like share the directory, and like if the machine is like 0.1.6, and if you share the Windows directory, then you can do this and just share, and you can just import all the files from the remote like virtual machine or something. In this way, you can collect all the binaries for each operating system you want in a very short time. And the actual result will look like this. I only imported some files, few files here. So it shows Microsoft Corporation here. And it will show all the files that it had imported. And if you look into, looks like usually many bugs are found for like a WKS svc.dll. So there are all the files here. Yeah, simple problem. So you can see all the binaries here, and you can select the files to diff. Here it shows the version string and the OS name, like XP, SP2, something like that, and you just need to press here start diffing, and it will take, this binary is not that big, and it will take like a few minutes to finish. So here's what file did I use? Yeah, here's the, after that it will show some function list like this, and actually it's from WKS svc.dll. It's a kind of it's a RPC service DLL, and it's called workstation service. And I diffed 2 binaries here, and the cool thing is that the unpatched binary doesn't have symbols because it was too old maybe. And the patched binary has the symbols. So actually you can know the exact name for the old binary, even though it doesn't have any symbols. So the first entry has, it actually had this name. So if you click this, then, oh, not this one. If you click this, yeah. Yeah, looks like it's having some problem. And if you click this, it will, yeah, this is actually, yeah, because it has some problem. This is actually from other function, netp manage IPs connect. You can find that the result here, you can see that the red parts are some blocks that has been inserted to the patched part. So the left side is the original binary, and right side is the patched binary. So the red parts are all the new code that has been introduced to the new binary. So it's fixing some problems. So you can find some interesting things like this one. It's comparing some byte with 5CH, which is, I believe, it's a backslash, I think. And other examples are like this one. The original code was just 1 block, and it's doing, I'm not so sure, it's doing very simple thing, but the patched binary is doing a lot of like, it's calling some net path canonicalize thing, so it's doing more processing, and it's also checking something like this, like it's comparing the length of the string. It means that there was some problem with some string operation, maybe. So you need to dig into more to get the real idea. And the cool thing is that if you click the Open IDA button here, then it will actually shows the result on IDA. It will be synced through some IPC. So I chose the first entry. This is the result. So if you look into this, it will actually colors the blocks. So actually you can actually analyze the vulnerabilities here yourself and use IDA, and you can just trace, because it shows the color, you know which blocks have the patches maybe, so you just need to trace the variables and registers here and see if it has any kind of security implications. So yeah, this is the demo that I can show now, and let's go ahead. So I'm going to show, because the demo doesn't show anything like a cool thing, right? So I'm going to show some real examples that has something really cool. So the examples here are just showing that the signature system that I invented really works. So if you have the patterns, then it will generate more like greater scores. So I'm going to show, I think, yeah, it will be like 3 examples that has one-day exploit that hasn't never been like released before. So, but don't panic. The old exploits, all the vulnerabilities already have been patched a long time ago. So, I don't think there will be any like wildlife exploits that will exploit this. Mm-hmm. So the first example is stack-based buffer flow. It's MS06 070. Yeah, looks like the picture doesn't work well here. Yeah, that's cool. So, yeah, this function has, actually I found this vulnerability using some static analysis, and it was very easy because it was found directly from the RPC call. Actually, there is some RPC, and you can find the RPC service code very easily using some tools like MIDA, and you can find this kind of vulnerability very easily, like a few years ago. Looks like the Microsoft patched a lot of RPC issues, so I'm very skeptical you can find these things now. If you can read these assemblies here, you can see that the argument here is user controllable. Actually, this function netp manage IPC connect is exposed through the RPC. So user directly control ARG0 argument, and it's going to ESI register, and it's actually used for the function for swprintf. So if you are familiar with any kind of a Stack Overflow, so swprintf doesn't do any kind of security checks. It doesn't do any kind of length check. So it will overflow EAX, the buffer EAX is pointing to. So the username, it's actually from the username variable, and it's actually from here. Username is here. and it's a kind of fixed size stack variable. So it will overflow some stack. So this was what I analyzed at first, and Microsoft released the patch, and this is what I got. So looks pretty cool, right? So the diff entry actually shows the entry that has the vulnerability right away, and it actually shows only 2 entries, and the other one has security implication score of 2, and the first one has 6, so you need to look into the first one. So you directly get into the result right away, even though there are 2. And the next example is also stack-based overflow. This is MS 06 to 070. Looks like, let me see. Oh yeah, this is still my example, yeah. If you look into the patch, this was just a SIS number, but if you look into the patch itself, it will show something like this. It's calling WCS-LAN API to check the original buffer, and it's comparing the result with 101H, which was the length of the buffer, the original buffer. So it's checking the original the buffer that is supplied by the user with some constant number. So here's the signatures from this example. So you can use string length or WCS-LAN or other string length check routines as a signature for stack buffer flow. So it's very easy. How about the other stack buffer flows? You might wonder the other stack buffer overflows will have same patterns. So let's see configure-worm example. It's MS08 067, and configure-worm exploited this vulnerability, and it looks like this. The diffing result looks like this. It shows 3 entries here, and you can see that the result, the first one has 20 here, so the others are like 1 and 0. So you might not need to look into like these 2. You just need to look into the first one. And what does it have? Yeah, it has something like this. It's a kind of mess here. So the red blocks on the left side, it's actually removed blocks. So they removed a lot of code from, probably from their source code. And the red blocks on the right side is inserted blocks. So they created a new code. So looks like they removed a lot of code and inserted new code here. So you might wonder, because it was a logic error, you might wonder you can find any kind of signatures there. Yeah, yes, it looks like so. Because the patched code is calling a lot of like a WCS-LAN, and it's comparing the result with some numbers here. So you can still use WCS-LAN. And that's not all. Actually, it's calling some safe string API call here. Looks like it's a little bit fuzzy here. So it's a string CCH copy W API. It's what I was talking about. It's a safe string API from Microsoft. So if you look up the MSDN, it shows that this API is used for like a more safer operations. It's doing like a null termination, and it's doing like other more security related stuff. And it's basically same as string copy, but it's doing more checks. So if you find some patterns like a string safe string APIs like this, you can conclude that the code must have some kind of security-related patches inside it. So you can use all these patterns, like all the safe string APIs and other like string copy underbar S thing. You can use all these as your pattern for like catching the patterns. And also, according to like SDL, you might need to like remove all the unsafe like a legacy string related operations. So you might use these patterns as a kind of detecting the vulnerabilities. So here's another example. This one is integer overflow, MS10-030 here. So it looks like it generates a lot of results here. And actually, the problem is inside the inetcom.dll, and it's used by Microsoft Outlook. And it's returning the problem. Looks like the first entry has something. So it's integer overflow, and if you look into the result here, it's calling ulong to ulong API here. So you might wonder what kind of API is this. It's 64-bit to 32-bit conversion routine, and it will convert any 64-bit routine value to 32-bit. And actually, the input for that conversion is coming from str to int, and the original data is coming from like user supplied response. So you might wonder what's the deal with the ulong long to ulong. It's actually converting 64-bit input to 32-bit. And during the time, it checks the original value is greater than maximum 32-bit value. If the 64-bit value is greater than that maximum 32-bit value, it will just return error code. So in that way, you can check whether it's overflowing the integer. So you can use ulong long to ulong function as the signature for integer overflow. And looks like somebody smells any kind of one exploit here. So if you go back to the list of functions here, you can see aside from that first one, there are a lot of other like a function list here that has been modified. It looks like they patched something without like telling vendors, security vendors or something like that. So here's the one that I found. The CIMAP for agent, it has a method called the resize message sequence number table, and looks like it has the same pattern here. It's calling ulong long to ulong, same API. And I look up some RFC. Looks like there are some message sequence number in IMAP, and looks like the client is managing the table for the sequence numbers, and looks like if the server is returning too many entries, like more than 0x3 FFFF or something, then it will overflow the table from the client. So you need to like return a lot of data from the server. So I don't think this is very easy to exploitable, but still it's exploitable if the user just waits for all the data to be transferred, maybe. So next example is also integer overflow here. So it's calling MALLOC here, and the length is actually from EAX here, and it's added by 0AH from the original value. So if original value like EDI was very big, it will overflow to like some small value, and it will create the integer overflow condition. So the fix is calling more CMP instruction here with original value. So it's checking twice. It's checking the original value is bigger than some constant number, and it's checking after the addition. So it's doing more comparison here. So you can use the number of CMP instructions. Maybe the patch might have more CMP instructions with it, and the unpatched one is not doing more sanity checks. So, and also it will come with some calls like malloc or hlolog or any call that ALOC patterns inside it. So maybe you can use this as a kind of sign for integer overflow. And next example is double free, and it's a workstation service, and it's actually found by Cody Pierce from DV Labs. And the original function was calling nappy memory free, but the patched one doesn't. So it looks like the original one was calling one more time. And the RPC is, actually this function was exposed through RPC, and the operation number was 0x14. And this means that the function is exposed through RPC, and you can directly access that function. So if you pass some argument to this function, then you will create a double-free condition. But the good news is that it will check access control list. It will go through access control list, so you must have some valid credentials to the system. So it's not anonymous attack or something. So looks like these informations are not like clearly reported anywhere. So you can find that details very easily, like doing the diffing, like this one. And you can create, you can deduce new signatures here. If you call free or NAPI memory free or any kind of free related functions, it might indicate some double free condition. And the next example is use after free. And I found that it's calling a lot of, like what is that, replace PTR functions. And the original one was, the function was called by like a 6 code locations, and actually the patched one was calling that replace PTR API like from a lot of places related to like event. And actually it's doing some kind of pointer replacement. So looks like the original code was missing that kind of pointer replacement. And you can also find some patterns like this, like old function didn't call free like in proper way. The old binary was calling the memfree directly without checking the reference count, and the patched one was calling the release method that is doing some kind of reference count check. So that the original one had that kind of problem. So you can use replace PTR or memfree as patterns here. But I believe it's until 11. So looks like we are running out of time here. So here another example is default user data thing. It's used for zero-day attack to Google. And if you look into that, it has 2 entries here. And this is a very important example actually. So actually the original code was calling variant change type EX with the same argument, and the source and destination was same. And actually the call to variant change type EX will destroy the destination data. So it was destroying some argument that has been provided from the other method. So the fix was, this is the original one, and this is the fix. And the fix was like using different variable here. So just using some local variable here, and they fixed it. And you can use a variant change type EX as a kind of signatures here. And looks like there are one more exploit, one-day exploit here, because there was only one exploit out there, but we find that there were 2 methods fixed here. So why they fixed 2, even though there were only 1 exploit known? So it means that they fixed something silently. And here's some something that I traced, and looks like if you read here, the original problem was from C persist user data class set attribute to method, and it's related to default user data behavior. But the fixed one had another class like a C persist data peer here. So I traced back where this class and method is used, and it's actually from the behavior of default user, default save history here. It's on the bottom, the last line, save history, and default save snapshot. So looks like there are another vector to exploit same type of exploit. So here's the exploit that I wrote. It's just POC. It doesn't have any kind of heap space code here. So it's using default save history here. The original one, the original exploit was using default user data. So people, the vendors might have created a lot of signatures related to this default user data, but you still exploit same kind of vulnerability using this behavior. So actually there are another one like a default save snapshot here. So maybe you can try to create exploit for this behavior. You can try that one. And here's something to think about. Actually, this is what I was talking about today. Could MS provide the information fully in the first place? They could just write some more one page of report about that in the first place, but they just missed it for some reason. I don't know if it's intentional or something, but they have some program called MAPP that is very cool. But looks like they are missing information, for some reason, maybe by mistake or intentionally. So this makes MAPP very unreliable, and it makes some problems with security vendors because they need to binary diffing themselves again. So, and here's another thing, like exploit writing and mini code coverage testing thing. So you might wonder that if you have something like Adobe Acrobat or something, then if you diff the points and it will generate, like I said, like a 10 or 20 meaningful results. And how can you write some exploit about that? You might not have any idea because you don't know about the format of all the stream for Adobe format. It's all proprietary. Then you might wonder how can we create exploit for that kind of stuff. So I have a little idea here I'm suggesting here. So this is the last part of the presentation. So you just need to do some kind of a code coverage test for some small parts of the binary, because you already have the diff point, like 20 or 30 points of functions, then you are very interested in. So you need to put breakpoints for that functions, like 20 or 30. So it's not full code coverage test. So it's very fast and effective. So I used some example from like a cool type font DOS. I used POC from ExploitDB, and it created. I reproduced the problem, and looks like it matched this one, the SIS number 7. This is the actual cool type font DOS. So you can just pinpoint which function is matched to which CVE number, actually. But how about the others? This one has CVE number, but how about the others? They are just patched without any kind of record. So how can you exploit these other functions? So maybe you can use static analysis, but it's not easy because it's using a lot of C++ code, and it's like a kind of hell to analyze all of them. So you use dynamic analysis here. It's I call it mini code coverage test, as I said. And you just Google random PDF document from the web, like a few thousand or something, and you execute Adobe Acrobat Reader against them. And you put a breakpoint for the point that you are very interested in, the diff point, as I said, from here. You have all the functions here, right? 1, 2, 3, 4, 5, 6, 7, 8. So you just put breakpoint for these 8 functions. Maybe you can use your debugger or immunity debugger or Pi debugger, anything you want. But I just used JIT with 0xCC technique. I just modified the binary with 0xCC and just put 0xCC to any function that I was interested in. And I assigned my favorite debugger as a JIT debugger. So if that point is hit, then my JIT debugger will come up and I can collect the thing that I'm interested in at that point. So it is very effective and fast. So after that, I could collect matching, like matching sample that is matching actually. I used the first example here, sub 0x or something. And I actually found the matching document that is hitting that point. But it's not like exploit, it's just base template for your testing. So you just need to because PDF documents are compressed, you need to decompress it, and you just need to change the bits inside it, and you can test yourself to hit the conditions that is matching the crashing. So actually, there was just out of bounds access vulnerability. So not sure it's exploitable, but I found that using this method within few hours. So you can try the same thing, and it's very easy. Even though you don't know anything about cool type font, you can use this method to find something very cool within few hours. So yeah, here's the last one, static taint analysis. I tried this one from a few months ago, but it's very, very hard because there are a lot of C++ issues. It's not traceable sometimes, and virtual functions, and it's very difficult. But I still created a tool called IDA-Tracker. It will trace the variables automatically for you, but it's still in alpha phase now. So I'm going to release it within a few months, and I will talk about this later. And here's the conclusion. So binary diffing can benefit IPS vendors or AV vendors or vulnerability assessment vendors a lot, because they can write some signatures that hasn't been disclosed before. And also it can be very useful for exploit writers too. And I propose a security implication score here, and looks like it's working very well. And dynamic and static analysis can be used for a binary diffing process, and usually looks like dynamic analysis is very helpful. And this is the last one. Looks like we don't have any time here, so the good news is that I will be at the Blackhat Arsenal. This is the first time here, and this is tomorrow afternoon, and it's from 1:30 to 6, and Arsenal booth number 1, and the tool name is Darren Grimm. So you can come here, and you can ask any questions you have, and yeah, we can communicate, and you can share your knowledge. And if you have any questions about the cool type thing, I can answer you anything with that. And thank you.